Welcome friends in the basic MPLS configuration class. Here I took three routers R1, R2, R3 and I took three loopbacks. One is 1.1.1.1 on R1. On R2 I took 2.2.2.2 and on R3 I took 3.3.3.3 and the subnet between R1 and R2 is 10.1.12.0 and subnet between R2 and R3 is 10.1.23.0. Here I've run OSPF between them, so if you check on R1 show IP OSPF neighbor, here you can see. And if you want to see show IP route OSPF, you can see here we have the reachability to 2's loopback and 3's loopback from R1. I can ping here, right? Same has been checked from R3 show IP OSPF neighbor. You can see show IP route OSPF. You can see I have the reachability to 1's loopback and 3's loopback and 2's loopback. So basic IP connectivity has been done. So for enabling the MPLS, we have to run few commands. One is for router 1, you have to go to configuration mode, type MPLS IP, right? Then MPLS label protocol LDP. Then MPLS LDP router ID is loopback 0. Then you have to go to the interface level and enable the MPLS by the command MPLS IP. It's done on R1. R2 also. MPLS IP, MPLS label protocol LDP, MPLS LDP router ID, loopback 0. Go to the interface, run the command MPLS IP. It's done. See, LDP neighborship has been up now with router R1's loopback, which is 1.1.1.1. For the R3 also, MPLS IP, MPLS label protocol LDP, MPLS LDP router ID loopback 0, interface fast ethernet 0/0, MPLS IP, right? Done. So here also on R1 you can see that the neighborship is up. And now for checking, you can check show MPLS LDP discovery. Now in discovery you can see that it's transmitting and receiving the information and the ID is 2.2.2.2. It's important. Show MPLS LDP discovery. Transmit received done. R3 also show MPLS LDP discovery, right? It's done. For binding, you can check show MPLS LDP bindings. Here all the bindings you can check, and for next you can check show MPLS forwarding table, right? Here you can see the tags, the labels. Now if you want to ping, you can ping and then you can trace. The trace command is like, in trace you can see that you will receive labels, right? Same also you can check from R3 ping, it's pinging, trace. So now it's not doing root lookup, it's doing label lookup, right? See 16, right? So this is the basic configuration of MPLS. So what are the commands which are important? I can note it down here. One is MPLS IP. For label protocol you need to type the command MPLS label protocol LDP and then go to the interface level, type the command MPLS IP. Through these four commands you can enable your basic MPLS connectivity, right? Thanks for listening. Hello friends, welcome in the class of BGP next hop cell concept. Here I took three routers where R1 and R2 are in AS1 and R3 is in AS2. I took the subnet 10.1.12.0 between R1 and R2 and I took 10.1.23.0 subnet between R2 and R3 and 1 loopbacks on each router, right? So I go to the R1 and done my basic BGP configuration. Router BGP1 neighborship is with 10.1.12.2, which is in same AS. The network which I am advertising is same, my loopback address. Done. Under R2 we are in the AS number 1, neighborship is 10.1.12.1, remote AS1, neighborship is 10.1.23.3, remote AS is 2, and the network which I have to advertise is this, right? Under R3 we are in AS2, neighborship is 10.1.23.2, which is remote AS2, and the network which I want to advertise is my loopback. Right. So it will take some time to come up the neighborship of BGP because it's slowest protocol. It's using TCP in its transport layer. So let's see on R1 what will happen if the next hop self command is not run yet. Here in show IP BGP, I mean it's still in conversion period. Show IP BGP, it will take some time. We have to wait for some time in BGP because it's first of all it's make the TCP neighborship. Once the neighborship will come up, it will go to the full state, and then after it will transfer the prefixes. So wait for some time, it will come up. Okay, there's some configuration issue. Let's see. Section router BGP 10.1.remote.AS2, that's okay. What is the problem? Okay, the problem is 10.1.23.2 remote AS. This is the problem because that is in AS1. Now it will definitely come up. See, it's come up. So it will take some time to show the prefix. .1 and I have advertised one prefix that should come here. Yes, now once you see on show IP BGP, you can see that you will have this best route which is received from router 2. So you have reachability, right? But in the meanwhile you have information about router 3's loopback, but that is not the best route. So what is the issue? So to check that, you need to check the next hop IP address 10.1.23.3. So what it says that if I am receiving a route from my eBGP neighbor, if I to receive a route from his eBGP neighbor and it will transfer that route to its IGP neighbor, it will not change the next hop. That means the next hop for 3.3.3.3 is 10.1.23.3. So this is the issue because R1 doesn't have the reachability to 10.1.23.3. This is the issue. So if you go to R2 and type one extra command, neighbor 10.1.12.1 next of self. So in that case, what it will do, what R2 will do, it will whatever update it will receive from R3, it will transfer to R1 with the next hop of his interface, which is 10.1.12.2. Right? So again, you have to clear the BGP. It's important. Show IP BGP. Now you can see, right? It's 10.1.12.2, and I have the reachability, right? So that is the reason I have the route for that, right? So I can reach. Why? We need to check. Show run section router BGP. What is the issue? We need to check it out. Is R2 have reachability? Yes. Then R3. Yes, now it's have. So you can ping it out now. Yes. So if you're not using the source IP address and you try to ping, it will not ping because by default the source interface is physical interface, and I have not assigned this interface 10.1.12.0 in under BGP. So that's the reason I took the source here, loopback 0, right? So this is about the BGP next hop self concept. Thanks. Hello friends, in this topology we will configure BGP between two different AS, right? R1 and R2 are in same AS, which is AS1, and R3 in different AS, which is AS2. So that means R1 and R2 are IBGP neighbors and R2 and R3 is EBGP neighbors. So what is the basic configuration I did till yet is on R1, if you type the command show IP interface brief, you can check I have assigned an IP address to the interface and on one of the loopback here. On R2 also I have assigned an IP address on both the interfaces and one of the loopback, and in R3 I have assigned the IP address on one of the interface and loopback. So for enabling the BGP we have to go to the global configuration mode, type the command router BGP1. Here one thing you need to remember, if you assign a router in one BGP autonomous system and again you are trying to configure another autonomous system, it will give you an error message that BGP is already configured, right? So go to the router BGP1. You have to manually make the neighbor. You have to make the neighborship between 10.1.12.2 R2. What is the remote AS? Is the same AS, and then you have to type the network command. What network you want to advertise in BGP? I want to advertise my loopback. So this way you can advertise your loopback in BGP. Okay. Go to R2. Under R2 is also the same as router BGP1 neighborship. You have to make the neighborship with 1, 12.1. Remote AS is what? 1. Again you have to create the neighborship with 3. The remote AS is what? 2. And what network I want to advertise? I want to advertise loopback of router 2. Done. On R3, just go to the global configuration mode, type the command router BGP2 neighbor 10.1.23.2 remote AS 1, and what network you want to advertise? It's 3. Done. So this is the configuration of BGP which we can do. You can check this. See, the neighborship is up now. Show run section router BGP, right? So this is the configuration which I did on R1. So if I type the command show IP BGP summary, by the help of this command you can check. See, your neighborship is with 10.1.12.1, version is 4, your autonomous system is 1, message received is 3, message sent is 4, right? The uptime is 40 seconds, but till now you haven't received any prefixes, so you have to wait. Yes, now you have received 2 prefixes, means once you type the command show IP route OSPF, you can show IP route BGP, you will see now here you can only see 1 prefix, right? So what is the problem? Here we can go on to the show IP BGP database table. Here we can check that 2 is our best route, right? That is the reason I can see it's in the BGP routing table. Here in 3 it's not my best route, because what is the reason? The reason is, once we have received a route from our EBGP neighbor and then I'll transfer that route to my IBGP neighbor, it will not change the next hop address. For that, what I have to do, I have to go to R2 and type the command router BGP1 neighbor 10.1.12.1 next hop self, right? So once I type this command, I have to create the BGP neighborship between R1 and R2. Now you can see that this is also the best route. So if you type the command show IP route BGP, it will take time to come up. It will come up soon. You have to wait. Let's check the R2 configuration. What is the issue? I have already advertised this. Okay. It's come up now, right? This is the AD value, which is 200. So you can ping now. You have to give the source command, which is loopback 0 here, right? I can ping. Okay, this is the basic configuration of BGP. Hope you like this video. Thanks.